I'm Seth Holder, and this is my Physics 2212 Lab 1 on charged tapes. Introduction to the lab. The goal of this lab was to discover the amount of charge on a piece of tape after we have charged it through our experiment, and how many electrons actually make up that charge. This was achieved through methods that are going to be explained in detail later in the video, but it was basically sticking two pieces of tape together and ripping them off so the electrons would transfer between the two and we would have a charged piece of tape. The charge was found to be able to create a force that was larger than gravity after we moved it close enough on a different piece of also positively charged tape. Some of the principles we use during this lab are Coulomb's law and Newton's third law. Coulomb's law is the force applied based on two charges and their distance apart from each other. And Newton's third law is just that your forces have to be equal. This is our experiments. For the experimentation, a piece of tape would be ripped off of another one to create a charge, and it was then moved close to other objects to see the reaction. We did this by placing a piece of tape on the table, and then placing another piece of tape on top of it, ripping it off. This caused electrons to move between the two pieces of tape, and to give us a negatively or a positively charged piece of tape. We then held it close to objects, like the negatively charged pin, just showing that it had a positive charge instead of a negative charge. We also held it close to other objects and saw how it was attracted to the other objects because of the charge on the tape. And in the final experiment, we put the two like charged pieces of tape, one on top of a little bridge that we had set up and another under it, and we saw the repulsion of the like charges, which caused the tape to move upwards. With this understanding, we could find the charge using a closed grip code because our forces up and down would be equal to each other. And in this experiment, the two pieces of tape were the system, and the table and the hands were the surroundings. The code we used, we can see that we have our constants, which will never change. We have the stuff we got from the experiment, which was the distance that it was separated, the mass of the tape, all of that, and the total atoms, which is just using the moles. We also use the weight and electric force in our code to essentially find our solution of the charge, and then we divided that by the number of protons to figure out how many electrons were removed from the piece of tape. This is some of the code that was used to make a picture or show us what's happening, and it's just showing our two spheres and their charges, and it shows the location as the locations are moving close or how far away they are, and we can see an arrow for the force and the gravity. This is the overall results. We can see the top piece of tape, which is represented by the red ball, has the force of the electrons pointing up, or the force of electricity, and the force of gravity pointing down, and we can see that they're exactly the same, causing the ball to not move at a set distance away from the blue ball. Some of the assumptions and potential errors that we could see during the lab is that the charge is assumed to be the same from when it is created to when it is tested, and the charges of both pieces of tape are assumed to be the same. The forces of gravity and electricity were set equal, but this leaves out any other potential forces. There could be forces due to air resistance or from movements in the air that could create minimal differences just from any wind that may have hit the tape, but we are just not looking at those. What if? What if electrons had a positive charge and protons had a negative charge? The repulsion between the two pieces of tape would still happen because they would both be the same charge. The difference would be that now it would be repelled by the negatively charged pin and any other negative object, and will be attracted by any positively charged object as opposites attract and like charges repel. Why? Why is it important to handle the tape as little as possible? This is because hands and other objects that are neutrally charged slowly neutralize the tape upon contact, and the electrons will transfer to the other objects it's touching, causing the tape to lose charge over time. In conclusion, through experimentation and physics laws, a charge was found for the pieces of tape. The charge found should be very close to the true charge because the assumptions and potential errors are so close to zero, or they're so minimal in our experiment.